So today we'll start part of module 4. So your module 4 contains two topics. One of them is color image processing. The second topic is I think multi-resolution image processing. Okay, or I should say wavelets. Okay, both of them are interesting. So part of it is actually color image processing, and rest of the entire module will be for wavelets. Okay. So let us start with color image processing. You might have seen in your textbook in mid pages, there are some special pages printed in color, especially for this particular topic. So how do you think the color image processing will be different from what did you study till now? Any idea how color image processing is going to be different from what do you studied till now? Number of bits in the sense what? What does it mean? Number of bits in the sense how it is different. So what sort of images, by the way, you have manipulated till now? What are they called as? They are not monochrome. If for per pixel, if for a single pixel, if at all you allocate one bit, if it is 1, it is white. If it is 0, then it is black. Such things are called as monochrome. A black text on a white sheet is monochrome. A blue text on a yellow sheet, that's monochrome. 1 assigned a one color, 0 assigned another color. That's monochrome. Okay. That means either the presence of the color or absence. What you have studied till now is grayscale images. So it contains, usually most of the images represented using 8 bits per pixel. Okay, 8 bits per pixel, where 0 is for black, 255 was for white, and in between there were so many colors. So when you say color image processing, now you have lot of colors other than blacks, whites, and grays will be popping up. So there will be lots and lots of colors. So when there are more colors, now I think we may not manage with only 8 bits. We have to go for larger number of bits. Okay. We will also study how to represent color images with only 8 bits or with only 4 bits. That also is part of our study. But basically there are two sorts of things. So when you say color image processing, the number of bits allocated will be more. That is first thing. Then the kind of measure you want to apply for different colors, maybe we have to take into consideration the human perception also. So you might have studied it in even in audio, right? So whenever you are processing things in audio, you might have observed we are not interested in anything about 20 kilohertz, because when you cannot hear such a thing, why process, right? That's it. And then anything more than 5 kilohertz also, you will make a lot of compromise. Most of the bits are usually concentrated. Most energy is usually concentrated in less than 5 kilohertz. What's the precise number? In telephone, it is 3.4, because that's where the actual voice occupies. So similarly, whenever we are talking about color image processing, first thing is increased size, increased number of bits will take into consideration. Second thing is human perception for different colors. So if at all there is a scope for some sort of reduction in size, we will definitely do that. And then the printing and displaying of color images, how they are going to be different. How do we generate them? How do we generate them? Because earlier it's a less amount of color would give you white, right? If at all you are trying to print something, maybe. So less amount of color, it would be probably you don't put a dye on a sheet, that would be white. If at all you put dye densely, that would be dark. Then you put the dye, the dots very sparsely, that would be gray in color. Now things are different. So that's why we need to understand some color basics. So let us do that. Okay. So this is the usual spectrum of colors. Okay. So just as the way we cannot hear anything above 20 kilohertz and we cannot hear much below 300 hertz. Similarly, the entire spectrum, whatever you call the light spectrum, maybe we do not see much below this particular region here and after this region. Shall I take a pen? Okay. So maybe our sensitivity before this red and after this violet. You remember this, right, from our school days. What is this? Vibgyor, right? Violet, what is that? Violet, indigo, uh, blue, yellow, and finally there is a red, right? R is for red. The frequency which is just before the violet, the V of the Vibgyor, we will call it as ultraviolet. Maybe it will have an impact. It has an impact, but we can't sense it, at least from our eyes. And then immediately after red, there is infrared, right? Immediately those frequencies, wavelengths, what we call them, right? You might have seen the impact of these. Whatever the visible light cannot see, infrared ones can, and whatever the visible light cannot see, maybe the ultraviolet, right? So we use these things, right? You might have seen infrared cameras. What typically humans couldn't sense, infrared camera can. Ultrasound scans, UV, right? There are so many places where you apply UV because the kind of action they have, even though not being visible. There are so many applications, right from mineral exploration, maybe, right? We had seen this in first chapter. Once again, we will see this particular thing. So as I said, the part of the topic color image processing will be on the science behind the color, the things that to be taken into consideration when you are trying to process them. And the part of the section will be to use colors to analyze grayscale images. How cleverly we can use colors to analyze grayscale images better. That also will study as a part of this chapter under the topic pseudo color image processing. So this is the typical white light, right? In our PU, we had this particular, we have done this particular analysis, maybe, right? A white light is made of so many colors. Now we understand what is this infrared and what is this ultraviolet. The thing just before violet is ultraviolet. The thing just after red is infrared. Okay. Anyway, let us continue. Let us continue. What else? There are so many things. There are so many things. Okay. So this is the range. Okay. This is the range. So there are so many frequencies. You can see there are so many frequencies. Now they are measured in what is the unit? You can see what is the unit here. What is this particular unit here? Now you can see we are not talking in terms of frequencies here. We are talking about wavelengths. Okay. So we are talking about wavelengths here. Okay, that's how usually we refer to when we are talking about color intensities, right? The numbers are also, that is the standard measure. So can we see all of them? Do all these frequencies, do all these signals illuminated on our eye create an impression of visibility? No. Okay. So it is only from 400 nm to what is nm? What is nm? Nanometer. Okay. To 700 meters. You can see this is the units are in wavelengths. Okay. Then afterwards there is a big spectrum under infrared and ultraviolet. You can see the compared to the color spectrum. You can see here the width is much more. Okay. But then a particular range that a particular range that. Okay. Now what author has to say? So for a color without any, for a light without any color, the monochrome, there is only one thing, it seems, called as intensity. Okay. What is the measure of intensity, by the way? What is the measure of intensity? So whenever you buy a bulb, LED bulbs, you maybe otherwise CFL, or otherwise the 15 rupee incandescent bulb. You see the units. Okay. Nowadays, government is trying to promote LED bulbs. So see the kind of performance measures. A 15 watt LED bulb and a 15 watt CFL. So whenever they compare the two things, they say the LED bulb can give you better lumens. It can give you much more light. So what are the things, by the way? So I think you are much more familiar with these things. So to be able to understand what are those units, you have to go through, maybe if at all you see a 7 watt bulb and a 9 watt LED bulb, that's when, or the 2 3 companies, whenever they are trying to, you know, take a claim that they are doing much better than their competitor, then you can see them talking about this intensities. Okay, you can see. Okay, what are the performance parameters? So there is something called as for achromatic uh, wide source, there is only this thing called as intensity, dark and light made. Okay, but then for a chromatic light source, there are three attributes of the quality. There is something called as radiance. Now radiance in watts, I don't know, I thought watts are for something, the power consumed. We will buy this argument. Then there is something called as lumens. Yeah, this is something which we can relate. Okay, the amount of energy received by an observer, amount of energy received by a observer. And then there is brightness. Okay, then there is brightness. So we will ask, right, 3 watt LED bulb is less brighter compared to a 15 watt LED bulb. That is common sense, but what they write on boxes is usually the lumens. Okay, so for a white light, but then there are so many parameters. So be curious on what is the difference between this lumens and the intensity, not the difference or the similarity. Okay, we better know the things. And again, once again, what are the wavelengths? 400 to 700. The violet in 400. So which is having more frequency? Violet wave will have more frequency, or it is the red one which will have more frequency? Lambda equal to C by F. So this is the one probably which will have more frequency. We are not into frequencies anyway. Okay, we are not into frequencies. Now we are talking light. We are into wavelengths. Okay, what else? What else is there which is very interesting? Now this is the, the thing with the eye. There is blind spot, then there is retina. Then we remember something, the rods and the cones, right? We remember in the first module we are talking about the rods and the cones. And which one is the one which is sensitive to the colors? Which one is sensitive to colors? Is it the rods or the cones? Which one is sensitive to colors? Is it the rod or the cones? Cones, right? So you can see there are rods. So as they say, humans are much more sensitive to the changes in the intensity rather than the compromises made in the colors, due to the large number of rods compared to few number of cones. Okay, and what do they say? Less sensitive to light than rods. Cones are the, but the cones give you an impression of colors. Okay, cones give you an impression of colors, but they are very few in numbers. There is some much more interesting thing about cones. What do they say? Now you can see there is something interesting here. So 65% of them are sensitive to red, 33% sensitive to green, and 2% sensitive to blue. That means you make some compromise in color blue and eyes can't sense it. Okay, if you make some compromise in color blue, eyes can't sense it. What is meant by compromise? Maybe instead of keeping the signals up to 20 kilohertz, maybe you make some compromise, keep signals up to 15 kilohertz in audio. Human eye can't, human ear can't sense it, because our sensitivity is mainly towards lower frequencies. This is also something similar. This is why we are interested in analyzing the perception of human behavior. So this is something interesting. Now this particular graph, by the way, there are so many things. The blue, red, and green are there. No. This is a thing which is of interest to me, and we will use it somewhere in the topics to come. Okay. And where do these colors lie, by the way? Red lies in 700 nm, green lies in 546 nm, and blue lies in 435 nm. Okay, that means if at all you have an LED and that particular LED emits light with a wavelength of 435, it will give an impression of blue color. Whereas if at all it lets out a wavelength of 700 nm, then maybe it will give an impression of red color. I don't know, I may be wrong, I'm just telling you fictiously. You have to do your own study. Just be curious and tell me. Now that I am asking you to glow an LED, so just you should be able to tell me what is the cut-in frequency for red, green and blue LED. Is it 0.7? A normal diode, what is the cut-in frequency for a normal diode? It's 0.7, right? I wanted to know red, green and blue LEDs. What are their usual cut-in frequencies? And I also want you to know, want you to tell me, are they operated in forward bias or reverse bias? An LED, does it operate in the breakdown region or the forward region only? Be curious, let me know. Be curious and let me know. And especially the cut-in frequencies of the red, green and blue light. Have you seen an yellow light, by the way? Yellow LED? What you have to do? If at all that particular thing, say if it is there in this particular range here, maybe some amplitude here, some wavelength here, then it would give an impression of yellow. Maybe here also it will give an impression of red. Okay, you might have seen in trainer kits, right? There are so many of them. In your HDL kit also there were those LEDs, right? You might have seen yellow ones. You might have seen yellow ones also. So I thought the color is due to the material that is covering the light and not due to the intensity that they illuminate. Or is it so? Have you seen the decorative LEDs? When they are switched off, they don't have any color. They don't have any color. So, but when they are turned on, they change the color. So are you not curious? How do they change the color? What is the science behind it? This is a small task which I want to give you. Be curious, how does it work? Second thing is I want you to go through that Wipro Smart Bulb. Have you gone through it? Amazon sells nowadays, those color changing bulbs. They cost how much? 600 to 1000 rupees. What is the science behind them? How do they change the color? Because the hardware is fixed, right? They are not changing the LEDs. I'm just curious. So be curious enough to go through some literature online and tell me what purpose do they serve. And using those bulbs, can you have some application which can be useful to general public other than a simple decorative application? Can you think about something? Can you think about something? Now at all, nowadays there are so many gadgets online. There are so many gadgets online used only by the rich for the weird purposes and not being useful to the society. If at all you can find some interesting applications, you don't have to start anything from scratch. If at all you can use existing devices for something creative, it still adds a value. Okay. So let me now you might have understood. If at all you want the light to look red, what is the wavelength that shall be illuminated, not illuminated, sorry, that should be radiated. And to for the light to look green, what kind of intensity that should be radiated? So remember the numbers from 400 to 7 nm, that is the range. Okay. That is the range. Even in agriculture, they say if at all you are going for the saplings, small plants you want to grow, maybe a coconut plant or a they mention that evenings, please make sure the sunlight in the evening does not fall on them, because they contain a specific frequency, wavelengths. So which are they? Infrared or ultraviolet? Ultraviolet energy. It's not good. It's not good, right? The way the photosynthesis activity or the kind of harm. Even they mention if at all you're going for ultrasounds or anything, not a good idea to frequently undergo ultrasound scans. Okay. Be curious. see the impact of light other than those wavelengths in the visible region. Okay, even though they are invisible, but they are having some weird impact on an individual, on any substance for that matter. Be curious, go through them. So that was that. Then we have studied luminance versus brightness. We are not into this particular thing. So what is the brightness? Perceived luminance. Okay, perceived luminance, and this particular thing looking dark in a lighter background, and the same thing looking brighter in the darker background. Okay, so that is brightness is something related to an individual's perception, whereas luminance is what that is actually there. Okay. So you have to go through this once again. You have to go through this once again. Relatively better, relatively brighter, as they call it. Now for the timing, let us go into, I think we all have done these things in our introductory topics. Okay. Our introductory topics. Now let us talk about the color generation. How does it work basically? Now the topic, the reason for this particular topic is, yes, colors are there by the way, but we want to know how they are generated as a source of light, and how they are generated when we try to print it on a white sheet. Okay, so there are two different approaches, because on a sheet in a room, if there is dark, if there is no light, the room is usually black. But a sheet, if nothing is printed, the sheet is usually white. Okay, so the approaches used are completely different. Okay, approaches used are completely different. And second thing is, when these particular colors, if at all you are somehow you are generating them, maybe on your CRT monitor, maybe on your printing sheet, but then just to able to communicate that print me a white or print me a dark pink color on the sheet, how are you going to communicate from the computer to the printer? Everybody shall stick to the same color representation. Okay, so what that would be? A generalized representation for color images. That also we will see. So basically the images are generated using, there are primary colors. Okay, and then there are the combination of them are secondary colors. Which are those? For visible region, there is something called as, for the illumination thing, there is something called as additive colors. And then you are trying to print something, then there is something called as subtractive colors. No color on a sheet gives you a white, whereas all colors put together in a visible light gives you white. So you might have understood. That's why this is called as additive, where addition of three primary colors will give you white, whereas no colors printed shall give you white on a sheet. So which are those colors, by the way? RGB, red, green, blue together shall give you an impression of white. And poor PPT preparation here, I think I should have copied from the textbook. Okay, you can see this is something color actually supposed to look much better. Okay, it's there better on the screen than on my laptop. Okay, so you can see the combination of red and green is supposed to give you yellow, the combination of red and blue is supposed to give you purple, and then a combination of everything gives you white. Okay, but then if at all you do this thing with your Fevicryl crayons, this is not going to work. Maybe this will, maybe this will. Will this work, by the way? Have you tried mixing yellow and magenta to get a red? No, no, definitely this doesn't work. You all have tried this particular thing. Anyway, let us buy this argument. Okay, let's buy this argument. Both of them to us. Okay, this one works anyway. If I mix this blue and red, I get magenta red. But if I mix all the colors, then I have to throw everything outside, because it's useless thing. It doesn't become white. Anyway, they have some, everybody is learning this particular thing also. We want maths, so we'll read this particular thing. So there are additive primary colors. Okay, then there are subtractive primary colors. So when you want to print something where colors are represented using additive representation, when you want to send the data to the printer, okay, printing blue on a printer, okay, so when you are sending it from the computer, it is going in a particular format, in the additive one. But when it reaches printer, you want to print, it shall be in a subtractive format, where the generation, the entire equation changes. Okay, so remember the importance of this entire thing. Okay, so even for the representation, colors can be represented using mixing approximate set of three primary colors. If at all you are not getting a better idea, go to paint and there is a very nice three fields where you can fill in all the colors maybe of red, green and blue. There is even luminance intensity. Have you tried this? Edit colors in normal paint. There also you can see these things. Let me take you to paint if possible. Okay. Now we are here in paint. You can see if at all I go to edit colors. Now here you can see. Let me simply mix 255. If at all I simply keep 255 in this particular thing, I get a color red. If at all I make this red as 0, and if I keep 255 here, it's a green. If at all I keep 255 of red and 255 of green, this is that cyan color. Cyan, I don't know how to pronounce it. CYAN. And if at all I make all of this as 255, I get a white. Okay, got this particular thing. And then there is something called as hue, saturation and intensity. Now what is this particular thing? Now let me move this bar. Let me move this bar from bottom. You can see the luminance and to the top. Say if at all I take the color 0, 0. Okay, now I can see, I just move this particular thing. See, now you can see I had made this 0 initially. So now I am moving this particular graph, you can see. Now can you tell me what is meant by luminance actually? So now this particular thing is luminance. You can see I am moving this particular bar. On one extreme corner of the bar there is black, and other extreme corner there is white. In between somewhere is my color red, which I had set to 255. So there is a formal definition of luminance in the textbook, but you might have understood what it actually. Then there is something called as hue. Okay, now let me make the saturation as 0, luminance as 0. So that's a black, and I make this hue as something like 200. Now can you sense the change here? Now see, let me move this particular thing, the cursor here. You can see on one extreme there is this hue, okay, on one side, then on other extremes. Now this hue is something horizontal. Now are you getting what is this hue? This hue is something which is taking you from the screen from extreme left to the right side. Now let me move this thing somewhere around here on this green thing. This is hue. Are you getting what this hue is? Something related to the color. It is something related to the information of color. You can see, as I'm gonna see here, there is red, then there are those purple ones, then there are violet, then there are blues, then there are greens and yellows. And hues are representing actually the colors. Lighter or darker, that is represented by the luminance. Colors lighter or darker, not brighter, light or dark. When you say light, extremely on other column it becomes white. Another extreme there is black. But then hue is something related to color, and then there is something called as saturation. Now, what is the saturation here, by the way? Can I make the saturation 0? Explore this particular thing. Explore the color thing on your own. Okay. So let us stop here. Let us continue tomorrow. Let us continue tomorrow.